Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to talk about logarithmic differentiation. So we have to use logarithmic differentiation to find the derivative of the given function. So we have the function y is equal to x raised to the 7x. And basically what the idea of logarithmic differentiation is, it's basically using the properties of logarithms, or in this case would be the natural logarithm, to simplify the function so that it's easier to differentiate. And that's basically what the idea is. Alright, so the first thing that we want to do is begin by taking the natural logarithm of both sides. So we'll take the natural logarithm of this side, which will be ln of y, and then the natural logarithm of that side, which is x raised to the 7x. And then we use properties of natural logarithm to simplify. So over on this side, obviously, we still have our ln of y, and then over here, remember, this is just going to end up being 7x times the natural logarithm of x, because remember, if I have let's say I have ln of a raised to the b, well, that's just going to give me b times ln of a, or the natural logarithm of a. So in this case, we've used one of our logarithmic properties to simplify this right-hand side here. Now, what we could do is differentiate both sides with respect to x. So what we're going to do now is just differentiate this side with respect to x. And we're going to differentiate the other side with respect to x as well. This is what we have. Now recall that once we start differentiating here on both sides with respect to x, this is really nothing more than implicit differentiation. So over here, we'll get 1 over y multiplied by dy over dx. Okay. Then over on this side, I could end up factoring out a 7, which would be a constant, obviously. And then I could just differentiate x times the natural logarithm of x, which will require us to use the product rule. So over on this side, we'll have 1 over y times dy over dx is going to be equal to 7. And then if we apply the product rule, we'll have 1 times the natural logarithm of x plus 1 over x multiplied by x, which we can then simplify. We'll have 1 over y multiplied by dy over dx, and that's just going to be equal to 7 times, if we simplify, this would be the natural logarithm of x plus 1. Okay, that's what we'll have after applying the product rule. Now what we need to do now is to multiply both sides by y, because the idea is to solve for dy over dx basically. So again, this is really just implicit differentiation, what we're doing. If you don't know how to do implicit differentiation, I do have videos on that as well. So if we multiply both sides by y, and I guess I'll write it out just to show you what happens. This will be 7 times y, and then we still have the natural logarithm of x plus 1. And basically what happens is the y's cancel. 1 times dy over dx is just dy over dx. And then over here we'll have 7. Now remember that y was x raised to the 7x, so this is 7x raised to the 7x multiplied by the natural logarithm of x plus 1, which will actually be your derivative, and that's about as far as you can go with it. So your final answer for this, when we take the derivative, it's just going to be dy over dx is equal to 7x raised to the 7x multiplied by the natural logarithm of x plus 1, and that would be your answer. Alright, so let me circle that for you, and that's how you do it. So logarithmic differentiation will come in handy as you move through calculus in certain situations, so it's best to work a couple problems so that you know how to do it. Alright guys, I'll see you next time. Thanks for joining.